What's going on, everybody? Welcome back to the blackboard. We're gonna do some ODEs. Not really, we're just only gonna solve some part of an ODE. In this example, we're gonna do, I guess, the new stuff when it comes to non-homogeneous ODEs. If you remember in lecture, to solve an ODE, a non-homogeneous ODE, we split it up into two parts, the homogeneous part and then the particular solution part. And so this example will focus on finding the particular part. If you want to learn how to solve the the homogeneous part, you should go ahead and look at the other videos that I have in the playlist or in the website, whichever you are first. But other than that, let's get started. So this one, we are given the function y double prime plus, or the ODE y double prime plus 16y is equal to 3t, and our particular solution is equal to c1 cosine of 4t times c2 sine of 4t. And so in order to do this, well, it's like if you remember in lecture, if the function f of t, so this part is our f of t, if its derivatives or its general form is similar to the homogeneous part, which is this portion here, then we have to do something else. If it's not, then we just use the general form. So as you can see in the homogeneous solution set, we have that the general form of f of t is not in it, so we can let our particular solution be a times e to 3t. And so when you take the derivatives, y prime would just be 3a e to 3t, and then y double prime will be 9a e to 3t. We're now going to plug it in into the original equation. So our ODE will now be equaling to 9a e to the 3t plus 16a e to 3t equaling e to 3t. So now this makes our lives pretty simple, because we can now divide everything by e to 3t, leaving us with adding 9 plus 16 together, that is 25, be 25 times a, and that is equaling to 1. So a is going to be 1 over 25. So now our general solution to this ODE will be the homogeneous portion, so cosine of 4t plus c2 sine of 4t plus 1 over 25 e to the 3t. So this wasn't so bad. Let's move on to the next example. So our next example is, we're given this ODE. The homogeneous solution is equal to c1 e to negative t plus c2 e 2t, and our function is 3x, well, supposed to be 3t, f of t. And again, our function, it does not look in any way like our homogeneous solution set, so we can let our particular solution be equal to at plus b, and so its derivative will be a, second derivative which would be 0, which, nice. So when we plug it back into the equation, we will get negative a minus 2at minus 2b, and that is equal to 3x plus 4. And so we can group these together, so we have negative 2at minus 2a minus, not 2a, minus a minus 2b is equal to 3, keep forgetting, it's supposed to be a t. So what do we do now? Well, we can just kind of group these together, so the 2at and the 3, they have to equal to each other. So this would be 2at is equal to 3t, making the t's cancel out, a equaling to negative 2/3, 3 halves, negative 3 halves. So we can plug in the other part, in which negative, well, I guess I'll just substitute it in, 3 halves minus 2b is equal to 4. So our b will be 4 minus 3 halves, that will be equal to 5 halves divided by 2. So this will be, b is equal to negative 5/4. So our general solution will be c1 e to the negative t plus c2 e to the 2t minus 3/2 x minus 5/4. So yeah, this should be relatively easy, as long as the particular solution is not part of the homogeneous solution. So we're just gonna go ahead and try one where it is. So in this ODE, we are given y cubed, or y not, it's not y cubed, is the third derivative of y minus y is equal to e to the t plus 7. And so right here is, we already have a problem. So e to the t, that is very similar to the C1 e to the t of solutions. So this is where that second rule comes into play. So our second rule is we just multiply it by the minimum t, or t raised to the s, where s is the minimum integer that's non-negative. And here's the other part. So you don't have to multiply it by everything. And so what I mean by that is we can pretty much separate our particular solution to being two different types of functions. So big y1 times big y2. And so our y1 will just be e to the t, the e to the t portion, and then the y2 would just be the 7 portion. So our particular solution is going to be equaling to t a e to the t plus 7, not 7, plus b. And so we only multiply t by this function, or y1, and then leave the y2 alone. And so when you take the derivative, y prime will just be, oh great, chain rule, a e to the t plus a t e to the t, and then our y double prime will be, yeah, I'll just write like that, a e to the t plus a e to the t plus a t e to the t. And so that would just be 2a e to the t plus a t e to the t. We're not done yet because we have to take the third derivative. So this will just be 3a e to the t plus a t e to the t. So now we can just plug it in. So now we have 3a e to the t plus a t e to the t minus a t e to the t plus b. And that is equal to e to the t plus 7. This is cool because our b is the only constant. So b is equal to 7, or not b is equal, yeah, b is equal to 7? Yeah, b is equal to 7. Take that back. B is not equal to 7 because this is supposed to be minus. It's minus. So b is equal to -7. Aye. And then what we can also do is these two are canceled out. So we're just left with a nice little 3a e to the t is equal to e to the t. These two cancel out. So a is equal to 1/3. 1/3? 1/3. Thus, our general solution becomes c1 e to the t plus e to the negative t over 2 times c2 cosine of root 3 over 2t plus c3 sine of square root of 3 over 3 2t plus 1/3 e to the t minus 7. So it's a little bit more work, a little bit trickier, but it is still doable. And now for our last one is a little bit more trickier. So as we can see, the sign is nowhere in the homogeneous solution. So we're going to let our particular solution be a sine to the 3t plus b cosine to the 3t. And why are we adding the b cosine of 3t? Well, I did say it's the function and its derivative, and the derivative of sine is the cosine. And so we're just gonna go ahead and do the derivative. So prime will just be 3a cosine of 3t minus 3 sine of 3t, and then adding this cosine will be much more clear as when we plug it into the equation. Everything will just kind of click. So this will be negative 9a sine of 3t minus 9 cosine of 3t. And this is supposed to be times b times b. So when we plug it in, we have negative 9a sine of 3t minus 9b cosine of 3t minus 3a cosine of 3t plus 3 sine, not plus 3 sine, 3b sine of 3t. Ooh, gotta move a little bit to the right. Minus 6 times a sine of 3t minus 6b cosine of 3t. And that is, well, we know it's going to be equal to 2 sine 3t, but what we can do now is we can cancel out everything or group things together. So we will have the sines, so sine of 3t times negative 9a minus 3a plus 3b minus 6a. Whoops, it's not supposed to be minus 3a. Plus 3b minus 6a. And then this will be plus negative 9b minus 3a minus 6b cosine of 3t. And that is equal to 2 sine of 3t. So because it's equal to 2 sine 3t, that means this part must be equal to 0, and then this part must be equal to 2. So now we have, grouping these together, negative 15a plus 3b equaling to 2, and then negative 15, or I guess negative 3a minus 15b equaling to 0. Do a little bit of substitution, we get that a is equaling to negative 5b, so this will just be 3b plus 15 times 5, so 4 to 60, 75. B is equal to 2, thus giving B equaling to 2 over 75 plus 3, 78. And then A will be equaling 5 times that, so negative 10 over 78. And making our general solution equaling to C1 times e to the something else, negative 2 and 3. E to the negative 2t plus C2 e to 3t plus, not plus, minus 10 over 78 sine of 2t plus 2 over 78 cosine of 2t. And so even though in our function we didn't have the cosine, it was necessary to add the cosine, because if it wasn't for that, we will have, for a, it'll be sine, sine, or sine, cosine, sine, and that would just kind of leave, I believe, an unknown variable that we do not know. And yeah, that will be pretty much it for this video. So I'll see you guys in the next video.